Okay.
Good. So it looks like we're into calculus.
Mm-hmm.
Is that correct?
Yep.
Okay, good. Because that's the only way I know how to do number one. If there's a pre-calculus way of doing it, I don't know what it is. They're just telling you that pre-calculus is the beginnings of calculus also.
Mm-hmm.
So how do I figure out where the maximum and minimum are?
I would just graph it.
Well, maybe it's not calculus then. You know how to take first derivative?
No. Well, it's got the little asterisk next to it, so we can use our calculators. We're barely starting into calculus, just trying to like ease us
So
into
this
it.
is not calculus. Okay.
There's some of it, yes and no.
Well, there is a calculus way of doing this that's rather easy. But if you haven't had derivative calculus, you can't use it. So yeah, the only way they can really have you answer this is with a calculator.
Mm-hmm.
Okay, so you're fine on that one. You direct me. Do we just want to go 1 through the end?
Sure, that works.
Okay. I can't do much with that first one. I could do it on my calculator and we could agree as to where maximums and minimums are and where it's increasing and decreasing. You have any questions about that?
No, I don't.
Okay. So let's do 2. So they want the area of the enclosure as a function of x. So what should we call this question mark?
What's this question mark?
What can we call it? Let's call it y. It'll be a more understandable problem if we let a variable equal it. I'm not sure why they made it a question mark. If we call it y, the problem becomes pretty easy. Okay. Now, the total length of fence used, well, first of all, they say write the area as a function of x. Well, right now, what is the area equal?
Just x times y.
Okay. They want it as a function of x only. What else do we know about x and y based on the amount of lumber we have or the amount of fencing material?
That it's 2x plus y.
Equals?
240.
So if we let y be a function of x, then y equals 240 minus 2x. I'm getting a delay here. I wonder why. In my writing, it's like everything's slowed down. So anyway, if I can label y as a function of x, then I can substitute it over here. So what's area become?
I'm sorry, what'd you say?
What does area become? Area was x times y. But what's y equal to?
The 240 minus 2x.
Okay, so what's area equal to?
Isn't it just 240 minus 2x times x?
And that's their answer. I mean, that is a answer for that. They want the area as a function of x alone, not as a function of x and y, but as a function of x. Now, if you want, you can distribute that. I prefer leaving it in factored form, but if you do distribute it, that's what you get. Area as a function of x. Up here, this was area as a function of x comma y. But because we had this second equation that related x and y, then we were able to define y as a function purely of x. Okay. What are the possible values of x that make sense in this problem? Is there any values of x that don't make sense?
Anything greater than 240?
Anything greater than 120?
I guess that's true.
If that is 120 and that is 120, we don't have any area at all because y is going to be 0.
Mm-hmm.
So x has to be less than 120, not even less than or equal, but less than 120, and it has to be greater than 0. So that's the effective domain. And these problems frequently talk about that. Is when you have these problems, you've probably seen the problem where you take a piece of cardboard, cut out the 4 corners of it, fold it up, you make a box. Similar kind of a problem. Doesn't make sense for x to be more than 120 or even 120. All right. What's f of 2 going to be?
Isn't it just 1 over -1?
Uh-huh. Number 4, what's the domain of that?
Isn't it -2 to infinity?
Yeah, what you do is you take everything inside the radical sign, and you make sure that that has to be greater than or equal to 0. And then you solve that. So x has to be greater than or equal to -2. So you're correct. It's -2 to infinity, but it's bracket -2 to infinity.
Okay.
It's not parentheses because it is allowable for x to be -2. You can take the square root of 0. You just can't take the square root of negative numbers. Do you use Windows 10?
Yes.
Do you use this Windows Inkspace ever?
No.
Mine's been acting funny lately. That comes with Windows 10. Yeah, it's been really hit and miss as to whether it works. And then I'm noticing a little bit of a delay as I do it. All right, let's look at what this means. That's what they're asking for.
For which one?
For number 6.
Oh, we didn't do 5.
We didn't do 5. Excuse me. I a little confused by all this other stuff on the page. Yeah, the following 3 transformations are applied to the graph y equal x squared. Okay, let's do them one at a time. What's the first one? Vertical stretch by a factor of 3.
Isn't it just 1/3 x squared?
Vertical stretch means numbers greater than 1. Okay?
Okay.
In other words, your parabola that you would have gotten with the original function is skinnier when you do a vertical stretch by a factor of 3. Because every point that would have been there is now 3 times higher. And excuse me, the effect is to make it skinnier. But stretches, when they're vertical, these numbers have to be greater than 1. Horizontal is the opposite. If this was a horizontal stretch factor, then it would be a shrinking, not an expansion. Excuse me 1 minute. Let me get a drink of water here. Just getting over the flu, and I still got a touch of cough. Okay, second one, horizontal shift by right of 2 units. I'm not going to erase that yet. Starting with that. In other words, we already did number 1. Now let's apply number 2 to it also.
Y equals 3x minus 2.
You need parentheses around the minus 2.
Yeah.
Dx minus 2. And notice why. The 3 is not being squared. It's only the x minus 2 that's being squared. And finally, a vertical shift up 4 units.
Just plus 4 on the end.
Yeah. All vertical transformations are outside of the function. All horizontal transformations are inside. When I mean outside or inside, you can almost assume parentheses, but not really. We're really writing this as f of x, not y. We're writing that as f of x. And now any transformation I have, if it's a 3, that's outside the function. If it's horizontal, it's inside the function. And if it's vertical, it's f of x plus 4, outside the function. So it's really much easier to remember those transformations if you think of them as being 6 in total, 3 vertical, 3 horizontal. Every time you see something inside, it's horizontal. Every time you see a number outside, it's vertical.
Okay.
Including reflections. Now, what I call a vertical reflection is a reflection over the x-axis. So that would be a vertical reflection, and it's outside the function. If I wanted a horizontal reflection, it would be inside the function, the negative sign. That would be horizontal reflection. So number 6. Guess let's do this the easy way. I was going to do it the more general way. Always start from the inside out on these kind of problems. In fact, on most all problems that have stuff that's nested, you know what I mean by nested?
Is it just equations in other ones?
Parentheses inside parentheses, or radical signs inside radical signs. What is this equal to? You start with the inside one. You don't start with the outside one. The inside one is 4, then you add 4, now you're taking the square root of 16 again. But you always work from the inside out. So what is g of 4 equal to?
Isn't that just 4 minus 4 over 3, which is 0, minus 2 is negative 2.
Okay. And now what is f of g of 4? Since g of 4 is 0, we're going to take f of 0. That's all you do. And you said already negative 2?
Mm-hmm.
Okay. Now let me try. Trying to figure out how to get rid of this delay. I'm probably going to need to reboot my computer and do that whole thing. Unplug my tablet, plug it back in. All right, determine the domain and range of that function. Let's do the easy one first. Domain, always easier than range. It's the domain.
So it's 2. So it's isn't it negative infinity, comma 2? And then is that our union? And then 2 to infinity?
Yeah, it's all real numbers except 2. And that is the way to write that. Negative infinity to comma 2, parentheses, because it cannot be 2, in combination with or union with 2 to positive infinity. Okay, now range.
Isn't that just negative infinity to positive infinity?
Not quite. Maybe. There's a horizontal asymptote in that function. Where is it?
It splits down both of them, and it goes through 2.
Well, let's put the vertical asymptote in there. We got a vertical asymptote like that, at 2.
Mm-hmm.
There's also a horizontal asymptote. What's the ratio of the coefficients? In other words, the degree in the numerator is the same as the maximum degree in the denominator. Whenever that's the case, whether it's x and x or x squared and x squared, the horizontal asymptote is the ratio of those coefficients, which is 1.
Okay.
So I have a horizontal asymptote at 1. Now, typically, these are hyperbolic in nature. In other words, it's going to look something like that. Okay? Now, the functions can never cross vertical asymptotes. So there's no way this function ever can be 2, as you can see by the function.
Mm-hmm.
Question is, the range looks like it goes from negative infinity to positive infinity with the exception of 1.
Okay.
Now, here's the thing, is that functions can cross horizontal asymptotes. So it's possible that this function might do something like this, cross it, and then come back to it. And if that's what happens, then the range is negative infinity to infinity. Well, how do we figure out whether it crosses the horizontal asymptote? Let's set the function. I know where the asymptote is. It's 1. So that's what f of x is if it crosses the asymptote. That has to have a solution, does it? What is the solution to 1 equal x? If I find a solution to this, then it crosses the horizontal asymptote. My range is going to be all real numbers. If I don't have a solution to this, then I'm going to have a gap at 1 in the range. Is there a solution to that?
I don't think so.
No, you get x minus 2 equals x. The x's cancel, and you get minus 2 equals 0, which means no solution. So I know there is no point where my function is equal to 1, which means it's the pink one, not the blue one, and the range is going to be either all real numbers except 1, or if you want to put it in interval notation, cannot be equal to 1.
Mm-hmm. Okay.
Okay? And it all has to depend on whether or not it crosses that horizontal asymptote. Functions can cross horizontal asymptotes or oblique asymptotes. Have you come across oblique ones yet?
Just a little bit.
Well, they can cross them.
Okay.
The ones they can't cross are vertical. All right, how do we complete the square in this? Starting at the top. Let me use pink because it works better on the black. How should I rewrite that thing?
Well, you can take the 2 out.
Well, more importantly, I want to gather those two terms together, because you always complete the square on just the squared variable and the non-squared variable. I set aside the minus 7.
Mm-hmm.
So the first thing I'm going to do is gather those two together and leave room to complete the square. Put my 7 out there. Now I haven't changed it. Now, in order to complete the square, this coefficient has to be 1. So you're correct. We want to factor a 2 out, but just from these two, not from the 7. Still leave room to complete the square. Again, no changes. It's always the secret to completing the squares. Make sure that when you go from line to line, you don't change anything. Now complete the square inside the parentheses. What do you get?
Don't you just take half of b squared? Just 1.
Half of b and square it. What do you get?
1.
Okay, now I've changed it. I just added something to the right side of this equation. What do I have to do to balance what I just added?
Do the same on the other side.
Not the other side. The other side is y.
Or with the 7.
So I'm going to do the opposite on the same side. How much did I add to the right side when I wrote in 1?
1.
No, that 1's being multiplied by a 2. So what I really added was this times that, which means I have to subtract 2 to balance it. So what I did was I added 2 to the right side and I subtracted 2 from the right side. So again, this equation identical to that equation. Now I'm ready to write it in Vertex format, which will be valuable because I can graph it really easily if it's in, well, it says just to find the vertex. So how can I rewrite what's in the parentheses now?
Can't you do x minus 1 squared?
Yes, that's the whole point of completing the square, is because once you complete the square, you will always be able to write that as a linear term squared. So, same equation as that, only it's in vertex format. Where's the vertex?
Isn't that just 2, -9? Or no,
That's the x coordinate of the vertex. That is the k coordinate, or the y coordinate of the vertex. That's h, that's k.
It's 1
So the
-9.
vertex is at 1, -9. Does it open up or down?
Up.
Well, finding the vertex is huge in terms of graphing it, but it's still not quite enough. In other words, I don't know where it crosses the x-axis. I need a couple more points. You can't really draw a parabola with just the vertex. I know that it opens up, but I either need to figure out where it crosses the y-axis or where it crosses the x-axis. Which one's easier?
X.
Actually, that tells you where it crosses the y-axis instantly. Where does it cross the y-axis?
I'm not sure.
You said x equal to 0. By definition, when you're on the y-axis, x is equal to 0. Set x equal to 0, it's always the constant that is the y-intercept. So that's why I say that's the easier one, because you're staring at it. Okay? Now the coordinates on that are 0, -7.
Oh, okay.
Okay, so that gives me the left side of the parabola. Still need a third point. Well, that point there turns out to be pretty easy to figure out. What must that point be if everything is symmetrical about that axis of symmetry?
2 -7.
Yep. And so to me, that's actually the easier way to graph the parabola. I didn't figure out the x-intercepts, but I don't need to. 3 points determine a parabola, and I got 3 points right there. If it would have said find the x-intercepts, well, I would have found them. Now, one way to find the x-intercepts is to factor that, and then you'll have it in x-intercept format. And that'll give you the x-intercepts, but it won't give you the vertex. But once they ask for the vertex first, then to me, the next easiest step is usually to calculate the y-intercept. And then take the point symmetrical on the other side. Here's our rectangle. Let x be the width. What's the length?
7 more than that, so just x plus 7.
Write the length as a function. Okay. Length equals what?
X plus 7.
Okay. I guess once you draw a picture, you get ahead of yourself. Write the area of the rectangle as a function of x. Area as a function of x equals what?
X times, or x and then parentheses, x plus 7.
Yeah, and I actually prefer that answer to x squared plus 7x. Find the length of the rectangle if its area is 60. What do? I've got an area function there. They're telling me the area. Can I solve for x?
I'm not sure.
Well,
Probably.
okay, we'll substitute 60 for the area. And we know that's equal to x times x plus 7. Now I do need to multiply it together because I'm looking at a quadratic. And now I need to move the 60 over on the other side to solve it. Hopefully I won't have to use the quadratic formula. You with me?
Mm-hmm.
Okay. Does that factor nicely? What do I need? I need factors of 60 that do what?
That add to 7?
Not add.
Multiply to 7s.
No, subtract. Whatever the sign is in front of the 60, that's what they have to do. In other words, the first part of factoring it is split up the x's, determine both signs. They have to be opposite. It's the only way you can produce a minus 60. Now I got to have factors of 60 that subtract a 7. Well, let's figure out factors of 60. Cut it in half, double it. Cut it in half again, double it. Cut it in thirds.
Wouldn't it just be 12 and 5?
Triple it. There we go. I just found it. 12 and 5. Where's the 12 go? Where's the 5 go?
Plus 12 minus 5.
So my two solutions for x are what?
Negative 12 and positive 5.
Which one of those doesn't make any sense?
Negative 12.
That's extraneous. So x is 5, but they didn't ask about x. They asked about length. So what's the length?
It's just you plug x into there. So just 12.
Mm-hmm. So the width is 5. The length is 7 more than 5, 12. The area is 60. Everything works. Except my drawing pad here. 12 we have more pages after this?
I can send you another picture. For a different
Okay.
page.
You want to? You might want to go ahead and do that now, so we don't have to wait when we get to it. Couldn't do it while I'm fooling with trying to get my Windows Ink workspace working here. Oh, I had to click it 3 times before it would work. All right, number 10. What kind of function is that? Is it linear? Is it quadratic? Is it hyperbolic? Is it cubic?
Isn't that linear?
It's linear. It's in the form y equal mx plus b.
Yeah.
Well, that's a straight line. As long as the straight line has slope, as long as it's not vertical, if it's vertical, it's not a function. If it's horizontal, it's a function, but it's not one-to-one. But notice if it's got slope like that, then it is a function, passes the vertical line test, and it passes the horizontal line test. That's what you need to be one-to-one. So yes, for that one. Now, the second one is hyperbolic in nature. In other words, 1 over x looks like this, with asymptotes both at x equals 0 and y equals 0. Would that be one-to-one?
I'm sorry, what'd you say 1-to-1 was again?
One-to-one, it has to pass the vertical line test and the horizontal line test.
So, yes.
Yes. And the only consequence of that -3 is what?
Isn't it just to the right? 3?
Yep. Moves everything to the right. Both ends of it. So it moves this part to the right by 3 units and moves this part to the right by 3 units, but it doesn't change the nature of it being one-to-one. It is still passing the vertical line test and the horizontal line test. It's just our vertical asymptote now goes through 3, not 0. And we still have a horizontal asymptote that goes through 0, but it's still one-to-one. Now, last one. If I had a function like that, is that a function? All it's got to pass is the vertical line test for it to be a function. Does that pass the vertical line test?
Oh, sorry, I was muted. No.
Yes, it does. No matter where I draw a vertical line, it only passes through one value, y.
Okay. Yeah.
Okay? So, it's definitely a function. Does it pass the horizontal line test?
No, because you can go through it more than once.
Well, horizontal line goes through that point, and that point, and that point. So it definitely does not pass the horizontal line test. Now, if we want to talk about what this function looks like, let's talk about x cubed. Y equals x cubed. This turns out to be just a transformation of y equal x cubed. It's hard to see, but what happens here is if you take your parent function, it looks like this. with a flat tangent line right there. Is that a function? That's y equal x cubed.
Yeah.
Does it pass the horizontal line test?
I think so.
Barely.
Mm-hmm.
Barely. There is a point right there where the slope of the tangent line is flat, but there's only one point. In other words, I cannot draw a horizontal line that goes through more than two values or more than one value. If I draw a horizontal line on this thing, right there at the one point that I'm most suspicious of, then it actually only goes through one value, and that's the one at 0. So this one does pass the horizontal line test.
Mm-hmm.
But the moment you start adding other terms like that, or even an x squared, if I was adding only a number, it would just be a vertical shift and it would still pass both. But when I add something like this, what it does is it puts a loop in the quartic, or in the cubic. The moment you have that loop, it loses its ability to pass the horizontal line test. So the answer is no. Let me real quickly pull that up on Wolfram Alpha, just to graph it for you. I suppose you could do that. I don't know if there was an asterisk by this one or not. Was there?
No.
So you couldn't do this on the calculator. Nonetheless, I'm going to show you what I mean. If I graph y equals x cubed, looks like this. Just the way I graphed it. That does pass the horizontal line test. It doesn't look like it does, because that looks like a horizontal line. But it's only flat tangent line at one point there. There's no line that crosses that thing twice. No horizontal line. But now, if I add another term, regardless of what it is, but if it's x, watch the little hook that gets put in this thing. Now it fails the horizontal line test. And it doesn't matter what it is. I could do an x squared as my second term. In other words, x cubed minus x squared still causes a little hook in there. The only thing that doesn't cause a hook is if I do a vertical shift. In other words, if I do x cubed plus 10, then I'm still looking at the x cubed function moved up 10 units, and it still passes the horizontal line test. So the key here is having another term. Any other x term at all will cause this thing to have two relative minimums and or it'll cause it to have a relative maximum and a relative minimum. Good thing to know for calculus. Are you going to take, what year are you, Sam? Are you a senior or junior?
I'm a junior.
So you will be taking calculus next year.
Mm-hmm.
All of this comes into play a lot more. I better not take this down yet. In calculus. All right, let's have a look at number 11. Two things, only two things, do you have to do to solve for the inverse of a function? First part. Domain and range are a little different. But to solve for an inverse, what do you do?
I'm not sure.
Switch the variables first.
Okay.
And then solve for y.
Okay.
And when I say switch the variables, I really maybe should put a third step in there. Turn your f of x's to y's first, before you switch the variables. It's hard to work with an f of x, whereas when I write it like this, same thing, Only now I can switch the variables and solve for y. I suppose I could say switch the variables and solve for f of x, and what you'd really be solving for would be f inverse of x. Might actually be a better way to think about it, but this is easier to remember. Put everything in terms of x and y, switch the variables, what do you get?
Switch the variables, so just x plus 1.
No, switch the variables from that. In other words,
Oh,
wherever you see y, put x. Wherever you see x, put y.
so just x equals y minus 1 over y minus 3.
Yeah, now this looks like it might be easy to solve for y, but it's not that easy to solve for y. But that's the second part of solving for an inverse, is to solve for y. In other words, once you've switched the variables, now solve for the variable that's hard to solve for. What do I do here next to solve for y?
Don't you just have to move the y's over to the other
Give
side?
me the next line. I don't care how you do it. Give me the next line that I'm going to write, and it's trying to solve this equation.
Can't you just multiply that x times 3? Or not x times 3, y times 3?
Do it.
To both sides, so you have y times 3 times x over y minus 1.
Not over. Y minus 1 is left all on itself, but right? Okay. Now what? Whenever you find yourself stuck, do whatever you can do. What can you do here? There's only one thing you can do.
Can't you add that 1?
No, that doesn't help.
The 1.
I got to get all the y's on one side. That's my goal, is to get all the y's on one side, everything else on the other, and then I'll be able to solve it. The only thing I can do here is distribute. You're right, I could add 1 to both sides, but that truly makes it harder, not easier. Whereas if I distribute, now I got xy plus 3x equals y minus 1. I feel like I'm writing in molasses here. In other words, when I write, it's showing it about a half second later. Okay, now I'm trying to solve for y. What's the next line?
Now, can you separate the 1 from the y?
The goal, if I'm trying to solve for y, is to take every single term with y on it, put it on the same side of the equation. Anything that doesn't have y, put on the other side of the equation.
Okay, so subtract the x, y over.
No, let's do it this way. Excuse me. In other words, let's move this y to the left. We're trying to solve for y, let's put y on the left. Equals minus 3x minus 1. You with me?
Yeah.
Okay. Now, how do I solve for y?
Because it's just x times y. Can you divide the x off?
Think factoring. Think factoring. What can I factor out from that expression on the left side of the equation?
The y?
What's left?
I'm not sure.
When you factor a greatest common factor out of an expression, what you're doing is dividing both parts of that expression by that greatest common factor. That's what's left. So I'm dividing that by y, I'm dividing that by y. Now I'm going to start writing up here. What do I have left?
X
Minus 1.
Dividing.
Is that not the same thing as xy minus y?
Yeah, I guess.
Okay. On the other side of the equation, I still have this. 3x minus 1. So now I can solve for y by just dividing both sides by x minus 1. There's your answer, right there. That is y. And what it really is, that's not the same y as we started with. Well, we didn't start with a y, we started with f of x. But it's not even the same y that I started with. That's y inverse. Or really, let's use the proper terminology that they started with. That's x inverse of f of x. Excuse me. It's written this way. F inverse of x. That's what they mean when they ask for the inverse. That's what we're looking for. And it's equal to this, what's circled in the lower right. Okay? Now, domain and range are a little tricky when you're dealing with inverses. First of all, your final answer may not have the same domain restrictions on it as your original thing did. But you have to pay attention to all domain restrictions from the get-go. So what's the domain restriction of f of x?
The 3.
Yeah, x cannot be equal to minus 3. Other than that, all real numbers. That domain restriction carries over, even if it doesn't look like it. It does. But because we have a new function, the inverse, what else can x not be also?
-1.
Positive.
Or +1.
Those are your two domain restrictions. Now, range. If I look at that as being hyperbolic in nature, then the range is not necessarily going to be all real numbers. There's going to be a horizontal asymptote where?
At the -1.
Not at -1. At the ratio, the coefficients of the two highest degree variables in the numerator, which is x, and in the denominator, which is x, they're the same, so we take the ratio of their coefficients, which is 1 over 1. So our horizontal asymptote
It's going to be
is y equal 1. So once again, we have a question of, can that cross the horizontal asymptote? If it can, then the range of this function is all real numbers, but we're going to find that if I set that equal to 1, we're going to do the math again. The x's are going to both cancel, and we're going to have 3 equals -1. So no. In other words, this is all reals. Do you remember what our answer was that I erased?
For the inverse,
Yeah.
it was -3x minus 1 over x minus 1.
Good. So that's f inverse of x. Now, we found a different domain restriction. It can't be 1. You can just never divide by 0. That's the bottom line. Now, what's the horizontal asymptote?
Let's see. So it's the -3x divided by 1, right?
No.
So
First of all, when you're talking horizontal asymptotes, you have to examine which variable is the highest degree in the numerator. It's x. Which variable is the highest degree in the denominator? It's x. They're both to the same exponent. And it doesn't matter. It could be x to the 7th over x to the 7th. If it's the same exponent, then the horizontal asymptote's the ratio of those coefficients. That has a coefficient of 1. Where's the horizontal asymptote at?
3.
-3.
Mm-hmm.
And erase that because it's going to confuse the issue. So the question is can it cross -3? Well, I'm going to plug in -3 and see if I can solve that equation. If I can solve it, then yes, it can. And that won't be a restriction. So now I'm going to have the same problem, right? In other words, I cross multiply, I'm going to have -3x plus 3 equals -3x minus 1. No way, Jose. 3 does not equal -1. It cannot cross the horizontal asymptote. So what is my range for the inverse function?
So it's -infinity. Oh, it can't cross the other one, right? The other horizontal.
Well, that deals with the domain. And yeah, the vertical asymptote, there was one at -3, and then there's another one at 1 on the inverse function. So those are definitely, you can never cross vertical asymptotes. Okay, so I notice that you give all answers to ranges and domains in interval notation, and that's the proper way to do it. But sometimes it's easier to just say all real numbers except. Do you agree?
Yeah.
Okay. Like the domain of that is all real numbers except x equal 3. That's easier than saying -infinity to 3 in union with 3 to infinity. It's just easier to say all real numbers except 3. So between you and I, we can talk like that. I won't take points off because you don't put it in interval notation. Okay?
Okay.
So the range of both our function is all reals and our inverse. No, excuse me. Excuse me. Where in the world did I get that from? Probably the dangers of using interval notation. Or not using interval notation. The original function does not cross the horizontal asymptote at 1. So the original function has a range, and this time I will use interval notation just because, and it goes up to the horizontal asymptote but never touches it. So knowing these horizontal asymptotes is huge for domains and ranges. So that's the range of the function. Actually, they didn't even ask that. They just asked for what the range of the inverse of the function was. Well, it's all real numbers except -3. Just as this was all real numbers except 1, this is all real numbers except -3. We've already proven that it can't cross -3.
Mm-hmm.
Bothered by one thing here. It's composites. When you do a composite function, your domain and range are the most restrictive of either function or the composite. With an inverse, I'm not sure that's true. No, I don't think it is. I think once you get an inverse function, then you're dealing strictly with that in terms of your domain and range. In fact, Might have been wrong on the domain of this inverse function. The domain might be all reals except x equal 1. In other words, I don't need to exclude minus 3. That's a restriction of the function, but it's not a restriction of the inverse function. The inverse function only has a vertical asymptote at 1. I don't need to concern myself with the minus 3. So the domain of the inverse function is all reals except 1, and the range of the inverse function is all reals except minus 3. Do you have answers on these?
No, I do not.
Okay. There's a couple of subtleties when you're dealing with composite functions and inverse functions that I sometimes get a little confused between the two. That's why I was hoping you had answers, is we'd be able to verify whether that's the right answer or not. I'm 80% sure that's the right answer. Did you send another one yet? Yeah, it looks like you probably did. We don't really have time, do we? Well, let's just have a look at it before I let you go. Do you have another appointment before your final?
No, it's the finals tomorrow.
This is it, huh? All right, well, I can't even give you extra time tonight. It's too bad. Some of these look a little more difficult. You know Newton's law of cooling?
Yeah.
Yeah, make sure you memorize that because it doesn't look like they give it to you.
I think she said she was going to give us a list of...
Oh, okay. Okay. Yeah, there's a lot of stuff on here for sure. All right. Well, good luck, Sam. And next semester is going to be trig?
I believe so.
Okay. You're taking it. You're taking pre-calc trig?
Mm-hmm.
Yeah. There are some pre-calc courses that the second semester they go straight into calc. But usually that's for people that have taken Algebra 2 trig. In other words, you can't really do calc until you've done trig. So you have to do trig. And you've had a little trig probably in your math career, but not the kind of trig you're going to need to do calculus.
Mm-hmm.
So, all right. Well, if I don't talk to you again before the holidays, have a Merry Christmas, Happy New Year, and I will probably talk to you next semester.
Mm-hmm. Thank you.
You're welcome. Bye-bye.